All right, in this video, we'll talk about segments, chords, secants, and tangents. How do we use those proportionality rules to then solve for measures? So there's two properties here, or two theorems. Chord's proportionality theorem. If two chords intersect inside of a circle, all right, so that one is divided into segments of length A and B, and the other into segments C and D, then A times B equals C times D. All right, so taking a look at this picture here, so we've got two chords in the circle. Here I highlighted them blue and red. All right, then A times B equals C times D. All right, so A and B, just to remember, are always on the same chord, and C and D are always on the same chord. All right, so that way when you label it, you get the formula set up correctly. The second rule here is secant tangent proportionality theorem. Right, if secants are drawn from a common point outside of a circle and then segments are labeled as below, then A times the sum of A and B equals C times the sum of C and D. All right, so again, we take a look at the picture. Here we got two secants. We label one secant A and B, C and D. A and B are on the same secant, C and D are on the same secant. Now, an additional thing that we also want to make a note here is that A and C are always outside. A and C are outside the circle. Okay? And then also, so you have to be mindful about this secant tangent proportionality theorem. Like, there could be multiple pictures that we're going to work with here. So obviously we have the two secant picture. So that was just like the one we saw. You may see two tangents appear. All right, so when you have two tangents appear, you have to be really mindful that there is no B and no D, as the tangents don't go inside the circle at all. And then we might have the tangent secant set up so that way one side is a tangent, so we just would have an A and then a secant and a C and D. So just be mindful about the different setups and how that affects the formulas. Okay, so let's take a look at some examples. Let's take a look at this first one. So we have two chords here. Right, here's my first chord and my second chord. Right, so that means we're looking for the lengths here. So we know A times B equals C times D. We got to label those pieces. So here's A, here's B, C, and D. Just make sure, again, that A and B are on the same chord, C and D are on the same chord, and you should be fine then. 12 times 8 equals X times 10, which gets us 96 equals 10X. Divide by 10 both sides. X turns out to be 9.6. All right, this next problem, here we have two secants. All right, if I were to highlight those secants, here's one of them. And here's the other secant. That tells us then we're going to be using the secant, two secant formulas here. All right, and then we got to label accordingly. So here's A and here's B, C and D. So remember, C and D are on the same secant, A and B are on the same secant, and A and C have to both be outside of the circle. Now, substitute what we know. 18 times 18 plus X equals 16 times 16 plus 24. All right, continue to solve this one. We're trying to get what X is. 18 times 18 is 324. And then subtract 324. So we get 18x equals 316. Divide by 18 both sides. We get x equals 17.5 repeating. Now, don't be surprised. You're going to get a lot of decimal answers for a lot of these problems. They're not always going to work out so nicely. So just be mindful about that. let's take a look at this one next. So again, this is two secants, so that means we're going to use the secant formulas to set up proportionality. Highlight our secant. So here's one secant, here's the other secant. Label. So here's A and B, C and D, and then substitute accordingly. Now be careful in this particular problem, right? Yes, A is X. We don't know what B is, but we know what A plus B would be, and that would be 35. Right, same logic applies with C here. We know C is 15. We don't know what D is. We could subtract it, but we could also realize that C plus D gets us 40. And that can save us some work then. So 35x equals 600. Take our calculator out. 600 divided by 35 gets us 17.1429. So x is about 17.1429. Okay. Last example here. So again, this is like chords, inside chords theorem. We've got our first chord and our second chord. Right, and we got our formula: A times B equals C times D. Right, label our label our chords accordingly. So here's our A and B parts, C and D parts, and then do the substitution. So x subtract 13 times x subtract 9 equals 32 times 21. Now we take a look at this one. We're going to distribute here. We got to do a little double distribution. It's going to end up being a quadratic. So that means we're going to have to use the quadratic formula to solve. This is a topic back from Algebra 1, maybe even middle school, just to refresh on how to solve quadratics. Usually I would, if this appears on a summative or formative, I would be giving you this formula. So you don't have to memorize this, but I would assume that you, to some degree, can work it through. But this is definitely a very high level question here. So distribute x times x minus 13, subtract 9 and x minus 13. We're doing a double distribution. 32 times 21 is 672. And continue the distribution. All right, when we're solving with a quadratic formula, we have to get 0 on one side of the equation. So we're going to move this 672 to the other side and combine like terms. We're going to get x squared minus 22x minus 555 equals 0. All right, and so that tells us, once we're in this form, what's A? A is 1, which is always the coefficient of x squared. B equals negative 22. And C turns out to be negative 555. All right, once we've identified those pieces, we can then use this formula and substitute the values that we do know. So we know that A is 1, B is negative 22, and C is negative 555. So once we got that plugged in, I like to take this in bits. We'll do what's the determinant, which is under the radical. We'll do that part first. So we get x equals, right? Opposite of a negative is a positive. So positive 22 plus minus the square root of 2,704 over 2. Square root of 2,704 is 52. Slight typo there. it's just 52. Now this will split up into two separate problems. All right, so we have an x equals 22 plus 52 divided by 2, and an x equals 22 minus 52 divided by 2. This side we're going to get 37, and over here we'll get negative 15. So when we're taking a look at this, negative 15 is not going to work because we're working with a circle. We can't have negative distances. So our final answer here has got to be 37. Okay, so this is the level 4. If you have any questions, bring them to class. Otherwise, have a good day.